okay, we have to follow the schedule. So speaking about the scores, the School of Coral Reef Restoration is important for Indonesia because there are many initiatives has been conducted in Indonesia since many years, but we don't have any kind of like place to sit together to learn what we have done and what needs to be avoid, what needs to be followed, what is the obstacle. So not everybody trying to do something and then find their challenges and then find their troubleshooting. So our objective is mainly for like everybody welcome, and no such technique is better than other techniques, but it is a matter of like it is based on the characteristic of habitat or the ability of the community to conduct their rehabilitation and restoration. And while we are doing this is also because we have our government also launched last year called independent campus, or like in Indonesia we said like MBKM, so Merdeka Belajar Kampus Merdeka, where students can learn from other universities, and we can invite many more scientists around the globe to share their interest or their knowledge and spreading out to our students and can be claimed as credit. That's why if they are attending this series of webinars, it can be claimed as 2 credits. So we providing like their certificate, and then at the end of the period of scores, we will issue such a certificate. So the scores is important because the government, there is like a really big movement of our government nowadays. Maybe you already hear about the ICRG, the Indonesian Coral Reef Garden in Bali, and this program will be continued. And then we need such like a knowledge or lesson learned that can be coming from everyone. So hopefully that by this is the 10th series after launching. So I think, and from this 10 series, we already have a lot of input. So we hear many things, and then, oh, okay, even like a small movement in such area, we learn from that, like, oh, okay, this is something. But no one knows before because they only kept in their area. So we need to come up with this kind of like a resolution, and then hopefully that there is like kind of like output from this serial meeting. So your input for this series of scores is very important. And then I'm actually very curious about to hear your presentation because here in our department also, there is like a division of marine acoustic, robotic, and instrumentation. And then many of them already studying about bioacoustic. So I think ideas, hearing something from after restoration is something very new. And then hopefully that we can learn from your presentation. Thank you very much, and thank you very much everyone for coming here. I think many people here already know about the scores. Then hopefully that every Monday at 15:30 in West Indonesian time, we will meet and then talking about restoration. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you very much. And I'd like to start by saying thank you all very much for inviting me to share today, to join your community here, your scores group. And yeah, thank you for inviting me, and thank you for welcoming me so generously. This is a group that I've heard about from several places already. I've heard about it through the work I've been doing recently with Trieste, and then also from other collaborators in Indonesia. And I've seen it popping up in lots of places. And I think it's an amazing group, really a wonderful thing to be doing, a wonderful thing to have set up. I completely agree that it's a very important thing to be doing, to share this knowledge, to share these ideas, to share this experience of different ways of doing restoration. I think, yeah, as you were saying earlier, in Indonesia, restoration is becoming a very important topic of conversation. There's, you know, you're seeing a huge amount of increased interest and increased investment and action in restoration. And I think that's not just in Indonesia. I think that's all over the world. I think Indonesia is, in a lot of ways, leading the world at the moment by doing the most restoration, I think, that than we can see in any other country. And other countries are trying to follow suit and will be following behind Indonesia in that. So I think these discussions, the type of discussions that are being had in this group are discussions that will be very important for the future of coral reefs around the world over the next couple of years, over the next couple of decades. And I think it's something really exciting that you are all doing. And it's a real pleasure and an honor for me to be invited and to share some of our work. And I look forward very much to discussing the ideas with you later and hearing from lots of different people on the call. I'm now just going to share my screen as we get started. Okay, here we go. And so, yeah, my particular topic of research interest, as has been mentioned a couple of times, is bioacoustics. So I've been doing this research with groups here in the UK, where I'm calling from today, with groups in Australia, and with groups in Indonesia. Over the last 5 or 6 years, we've been doing various different experiments, listening to coral reefs and trying to understand what we can learn about reefs by recording the sounds and the things that we can hear on a reef, as well as what we can see. So today I'd like to talk a little bit about some of the work we've done in the context of reef restoration, and how we think that thinking a bit about what you can hear on a reef, and thinking maybe slightly differently in that way rather than the usual way of what we can see, why that might bring some benefits to the way we think about and the way we do coral reef restoration. So before I start this, I have so many people to thank. I'm sure you all know this feeling when you look back over the research and the work that you've done over the last 5 or 6 years. You think, oh, there's so many people to thank and so many organizations to thank that it's not possible to do it in one slide. But here at least are some of the people that I'd like to thank, because they have been a very important part of the work that we've done and the work that we are doing going forward. It wouldn't have been possible without these people and organizations, and they're all a real joy to work with. They're wonderful collaborators to have. And then to start to bring us into this theme of bioacoustics, I think it's nice to spend a while just thinking about the purpose of restoring reefs and what we are trying to restore reefs for. So I think there's around the world, we're seeing a lot of programs are getting very good at regrowing coral. But I think now is maybe the time that, as a global body of reef restoration practitioners, we need to start thinking not just about growing coral, but about growing a whole reef and a whole functioning reef ecosystem. So we can understand, you know, not just to bring back individual coral animals and coral on the seabed, but try to recreate the whole reef ecosystem and everything that it provides and all the ways that it functions as a whole ecosystem. I think this quote from a recent United Nations Environment Programme report, I think this highlights this a little bit. So coral reef restoration is increasingly advocated for as a management strategy, but there's a limited understanding of its effectiveness in supporting the maintenance of ecosystem services. There's a lot of fancy words in that quote, aren't there? But I think what it's getting at is that we understand how to regrow the coral, but I don't think we fully understand yet what that means for the whole reef, and then what services that reef can then give to people. And so this schematic that I've drawn down here is really just a way of thinking about all the different things that coral reefs provide and bring that are beyond just the growing of coral. So, you know, for example, here we can regrow that coral, but is the coral reproducing? Is the coral creating a biodiverse ecosystem? You know, are there important ecosystem functions coming back? So are we seeing the herbivory returning as the fish returns? Are we seeing structural complexity come back? You know, are we seeing the fisheries potential increase? Is the carbonate chemistry being altered? And there are many, many other labels I could put here as well. And then this little corner here, if you like, this is where I am, and this is where my collaborators have been researching. We're interested in whether the soundscape of a reef comes back. So it's just one little example of how we can look at a reef in a way that is more than just its coral. And so, of course, we could do this with all these other ecosystem functions as well, but we've chosen to work on the soundscape as our speciality. When we think about a soundscape, I think it's useful to start by just taking a step back and thinking what it's actually like to be on a coral reef. You know, what's it like when you're underwater? And I think because it's a completely different sensory experience, isn't it? It's very different to being on land. And I think this picture here sums up a little bit about how it's different. And that's because in this picture on the right here, you can see things that are very, very close up, can't you? And you can see them in quite a lot of detail. You know, you can see the textures and the colors, and, you know, you can see all the different shapes and the crevices, and you can see a lot of detail very close up. But when you look on the left of the picture out in the blue, you can't see very much at all. You can't see very far at all. There's a real difference there in the distance at which you can perceive different things on a reef, and from where you can get information. And I think there's I think that's something that we find on a reef. The distance at which our senses are working, it is quite different to how we are used to on land. So on land, we're used to being able to see a long way and to pick up cues visually from distance, and we can see for miles. Whereas on a reef, we can only really see the things that are close. And even if the visibility is really good, you know, we talk about like 40 meter, 50 meter visibility being really excellent, you know, that's still not very far at all, is it? And so the ways that we can get information underwater are very different to the ways we get information on land. We can hear a long way underwater, but we can't see very far at all. And we can hear a lot underwater, partly because the sound travels well, and also partly because these underwater ecosystems are very noisy places. There's a lot of animals that are using sound as part of their everyday life. And coral reefs are the noisiest ecosystems of all marine ecosystems. They're the noisiest ecosystems in the sea. That's because all these different animals are chattering away, making different noises for different aspects of their life. So here's a few examples. Here are some things I've recorded on coral reefs over the years. So the first noise will be very familiar to you. It's the sound of snapping shrimp, and this is like the backing track of coral reef sound. Wherever you go in the world, any time of day, any time of year, you put your head underwater on a coral reef, you will always hear this noise. Probably very familiar to you all, that crackling sound. That it's like static or something, isn't it? And it's the sound of many of these snapping shrimps, all living within the corals and in the matrix of the reef, clicking their claws and making this snapping sound the whole time. And then if you listen very carefully, at certain times of day, you can hear punctuated through that sound, the sound of fishes. And they make all sorts of different noises. So this is the ambon damselfish, making this little whooping sound. This is a clownfish or an anemone fish, making like a popping sound. These are the sergeant majors here. They're making this growling sound. And then there are many fish that we hear the noise and we've recorded the sounds, but we don't yet know which fish is making these noises. So there's a lot of mystery still in this area. It's a new area of science, and we have a lot that we still have to find out. So there's some mystery noises, we don't know what they are. So here's one of them. I always think that fish sounds a bit like it's laughing at us, like it knows that we don't know what fish is making the noise, and so it's just there having a laugh at us. And then this one as well. So lots of weird and wonderful sounds on coral reefs. Some of them we know what they are, we know what fish is making the noise. Some of them, it remains a mystery, we still have to find out. And I think it's fun to listen to reefs because of all these weird sounds, but I think it's also important to be able to understand the sound, to be able to record and understand the sounds that we hear on reefs for a couple of reasons. So the first reason here is summarized in this diagram, and that's because I think we can monitor diversity better if we listen as well as looking on reefs. And that's because when you take a visual survey of a coral reef ecosystem, so you swim along with a clipboard and you note down all the animals that you can see. That's demonstrated by this green circle. You will see some of the reef animals. You'll see the butterfly fish and the parrotfish, the damselfish. You'll see, some sharks if you're lucky. You'll see rabbit fish. But you're actually not seeing the whole reef community, are you? There's lots of these cryptic fish, lots of nocturnal fish that you will never record. If you listen on a reef, it's kind of similar. It's overlapping. You can hear something. So you hear a lot of the shrimp and you never see any shrimp. And you hear like toadfish, and sometimes you'll hear big eyes, and you'll hear squirrelfish and soldierfish. You'll hear some of the damselfish and the butterfly fish, the batfish, but some of them you'll never hear. So the sharks, for example, although you see them, they'll never make a noise. So you'll never hear them. And so I think by using both acoustic and visual surveys, you can get a much better picture of the diversity of a reef than you can if you only use one technique. So by using more than one technique, it's possible to get a more holistic picture of the diversity of a coral reef. And then the other reason that I think it's important to listen to reefs is that reef sound has a very important functional role on coral reefs. And that's because many of these juvenile young fish, and even some invertebrates, are using the sound of a reef as a way to navigate back to a reef at the start of their life. So unlike in the Disney film, where the baby fish are swept out to sea and then they get directions from friendly sea turtles and then go via an aquarium in Sydney and they have this amazing journey back home. This journey does happen in real life, but the bit the film missed is that these fish are using sound as a way to hear a reef from a long distance. They'll be out here somewhere in the blue, in the open sea. And because these reefs are noisy places and because the sound travels so well underwater, they can pick up the sound from distance, locate where the reef is, and come back to a reef. And so that's something that was discovered a couple of decades ago. There's a lot of work in Australia, particularly, where they started to understand the importance of reef sound in guiding this fish homing behavior. And when I started a PhD in coral reef bioacoustics several years ago, in 2016 that was, and I went to a place in Australia called Lizard Island. Lizard Island is in the north of the Great Barrier Reef, and it's a place where over those years from like 2012, it was quite healthy, and then it got hit really, really severely by some very severe damage. So in 2014, this was the strongest cyclone ever recorded on the northern Great Barrier Reef. So the strongest cyclone ever recorded in that area that hit the reefs. And then the very next year, this was another very strong cyclone, came from the opposite direction, but it hit the same reefs. And then later that same year was mass bleaching and a really severe bout of bleaching. And so by 2016, when I visited these reefs, they were really, really degraded. But what had previously, this was an area of Australia in which people had done a lot of research. They'd done a lot of work on bioacoustics. And so there were a lot of recordings from 2012 from when the reefs had been healthy, from when people have been doing research then. So when I arrived in 2016 on those reefs, the first thing I did was I listened to them. I wanted to know what all this degradation had done to the soundscape. And so I took recordings pre and post degradation. I went to all the places where in 2012 they had recordings. I took the same instruments and I went to the same places at the same time of year, at the same time of day, and I repeated those recordings again to see what had changed. And what I heard was, I was quite shocked by what I heard, because this is an example from one of those reefs. This is what the reef sounded like in 2012 before the damage. And then just 4 years later, you can really hear the difference where the snapping shrimp sound was super loud in that first one. In the second one, it's much more muted. You can start to hear the waves over the top because the biological sound is so much less. And as well as being able to see the difference on these reefs, you can hear that difference. This is just ways of quantifying that difference in sound, just ways of putting numbers on sound. So you could hear it with your ears, but we have computer techniques to describe sound. So we talk about sound being acoustically complex, or the acoustic richness of a sound. The snap rate is the number of those little snapping shrimp clicks you can hear. And the sound pressure level, this is just like the volume, really, how loud the sound is. And you can see that in all of the cases, as you could hear with your ears, these reefs before the degradation, when they were healthy in 2012, that they had higher values of complexity and of snap rates, and they were louder than the green boxes, which is the degraded reefs in 2016. And so it's sad to hear the collapse of the reef, but I think it's also important because, as we were talking about before, these fish are using sound as a way of getting from the open ocean towards the reef, and using it as a cue for navigating and a cue for homing back to reefs. And so we wanted to know, what is the effect of these reefs going quiet? Is this problematic for these fish or not? And so we ran two experiments in order to test the preferences of these recruiting fish, both at the stage when they're out in the deep blue sea, listening out for reefs from a long distance, and also the stage here when they're coming back to a reef and then settling down. And so we had two techniques that we used. When they're out here in the blue, we use this piece of equipment. It's called a light trap. And so this is a box that just floats in deep water. The fish can swim in through tapered slits and they can't swim out again. And we attach a loudspeaker to these different light traps. And we look at the impact of changing the noise that we play on how many fish are attracted to the light trap out in the deep blue sea. And then close here, when they're back on the reef, we assess the actual settlement preference of the fish by using these patch reefs. So we make just very, very small patches of coral rubble. And then fish will settle onto this rubble. And then we can, by playing different sounds using a loudspeaker, we can assess how changing the sound of these rubble patches changes how many fish will settle onto them. And so we did both of these in what we call a triplicate design. So our experimental setup was that these are the light traps, these are the patch reefs, and in both cases, we have three different types. So we have the post-degradation, the quieter degraded reef sound from 2016 here. We have the pre-degradation, this is the healthy reef sound from 2012. And then we had ambient sound. And this is just the sound of an empty open ocean. We recorded it where there's no coral reef at all. It's just like an experimental control. So it's pretty much silent. And across all of these three treatments, we then measured the number of fish that were attracted to each of those light traps or patch reefs. And we said, if there's no impact of the sound, if the sound is not important, then we would expect, on average, 33% on each of those, right? You'd expect an even number of fish going to each treatment. And so you'd see 33% on each one. But actually what we see is this. We see that on the healthy pre-degradation reefs, we get quite a lot more fish. compared to on the degraded reefs, which actually are no more attractive than the sound of an empty open ocean. And so when the sound of a reef collapses, when it becomes a degraded sound, fewer fish are attracted to that reef. And so I think this is why it's important to be thinking about the sound of a reef when we're restoring a reef, because there's a worrying potential here that as a habitat degrades, the sound of it will change. When we have that acoustic change, there is the potential for that to lead to reduced recruitment. And if we get fewer fish arriving on these reefs, then maybe that exacerbates degradation or it prevents recovery. You know, we know we need the fish to come back in order for the reef to recover. And so in order for the reef to recover fully, I think we need the soundscape to recover as well. And so we published that here. This is my old name. I should have said at the start, I'm Tim Lamont now. I used to be called Tim Gordon before I got married. I changed my name when I got married. So yeah, I'm not plagiarizing someone else's work here. I just changed my name. And so this was quite a depressing experiment and a depressing paper that we did. But we then wanted to think more positively about reef sounds. How can we use this reef sound and how can we use it in a way that is useful, and maybe in a way that is useful in a restoration context as well? So then halfway through my PhD, I met some of the people at a conference who are working on the Mars Coral Reef Rehabilitation Program. I'm sure some of you will have heard about this program, maybe worked with this program already. It's a program in Southwest Sulawesi, based out of Makassar. And they're working particularly now in several places around Indonesia and around the world, but in particular, their program started at two islands off the coast of Makassar called Pulau Bantasua and Pulau Badi. And at these two islands, they developed this way of restoring reefs using these reef stars. They used to call them spiders, they now call them reef stars. And they're attaching coral fragments to these sort of hexagonal metal frames. They're planting these frames over the seabed. You can see filling in the gaps in between where there's been degradation to cover the rubble. That does two things. It stabilizes the rubble to stop everything washing around. And then it also allows these corals that they've tied to the reef star, gives them a platform to grow. And so you get quite fast coral growth. And what they'd seen in this program was that they've been able to go from areas that were rubble fields to cover them with reef stars and then to create a lot of coral. They've been successful in regrowing the coral, but they wanted to know, have we brought back the soundscape as well? You know, are these reefs sounding right? Because that will tell us, first, it will tell us more about the number of different animals that have come back, because many of the animals we hear, we never see. And also it will tell us whether these reefs are attractive again to juvenile fish, whether these reefs are likely to attract more animals, or whether they don't sound right, you know? And so we worked with this program to include some acoustic monitoring in their monitoring program. They were already measuring things like coral cover and rates of disease, and they were measuring fish community and doing lots of surveys like that. We helped them to add acoustics to their surveys. Oh, sorry, I forgot this slide was here. This is just some of their numbers. So they've done 40,000 square meters of restored reef, and they've planted 300,000 corals, and they've installed these stars. And yeah, they've seen that they can increase the coral cover, and the fish that they can measure, they see increases, but they wanted to know more about, you know, does the soundscape come back as well? And so this is, you know, it's starting to install, as you can see here, just in the shadow, there's a hydrophone here. And so we went and we took recordings on the reefs around this area. And the first job was we needed to characterize the soundscape of the area on healthy reefs. And so we went and we recorded all the different sounds that you can hear on these reefs. And these are some examples. I played you some of these sounds before, some of these weird sounds that I started the presentation with. And we classified all of them. And, you know, so the knock, that was the one that we thought was a clownfish. And the purr, this was the one we thought was a sergeant major. The whoop somewhere, this was the one we think is an ambon damselfish. And then lots that we didn't know what they were, but we could tell they were distinct sounds. You know, we keep hearing this croak sound, this grunt sound, and we characterized them all. identified all these different sound types that were happening. And then our question was, when do you hear these sounds and where do you hear them? And so we split them by time of day. So for example, this scrape sound, we think that's a sound associated with the feeding of like parrotfish or surgeonfish. You know, when they're biting on the reef, you can hear the scrape happening. So you hear that mainly in the day because these fish are feeding mainly in the daytime. And then these other sounds, the knock and the grunt and the growl, you hear them mainly at sunset and sunrise. It's quite a busy time on a reef. And then there's some sounds that you only hear at nighttime. So the buzzes and the purrs and the croaks, these are nocturnal fish that you never see, but when we take recordings at night, then we hear them. And you can see across all of the times of day, in most cases, we're seeing more of these sounds on healthy reef, that's the green bar, and on restored reef, that's the purple bar, than we are on the degraded reef. Not all of them. So for example, the croak here, this is obviously being made by an animal that is still there on degraded reefs. In fact, there's more of it on the degraded reefs than the healthy and the restored. But on most of them, the scrape and the knock and the grunt and the buzz and the purr, we're seeing more of them in healthy and restored habitat than we are in the degraded. When you add that all together, when we combine all of these sounds into what we call the phonic richness, this is just a measure of how many different sound types we're hearing. Then we can see that the restored reef is back up to the levels that we saw on the healthy reef, and substantially more different sound types than in the degraded reef, which is lower than both of those. And then when we use multivariate analysis to look at this pattern, we can see that, again, the healthy in green, you can see that circle here is very similar to the restored in purple. And they're quite different to the orange, which is the degraded. You can see that the different sorts of soundscape that we're hearing, the restored reef, although it would have used to sound a bit like the degraded, has now moved over and it now sounds more healthy. So it's quite an encouraging finding this, that in this case, when the coral has been restored and when the fish start to come back, then as well as seeing the difference, you can hear the difference and the soundscape returns as well. So it's a really important sign of success for this project. We then thought that this was an encouraging thing to be able to do, but one of the problems was that this is very expensive. So these hydrophones that we were using here, this is the machine here, and it's this one here. It's called a sound trap, and it's a very specialized piece of equipment, an expensive hydrophone. It costs about $3,000 for one of them. And we thought, well, this is no good. This is far too expensive for anyone to be able to use, really, in most of the world. And this is only going to be a useful thing if lots of people are able to listen to reefs. And so we thought this needs to be cheaper. And this is from this figure here is from a review we did where we compared the devices that people use to take sound recordings underwater with those that they use to take sound recordings on land. And that's because on land, many people are already listening to soundscapes and using acoustic recorders to measure biodiversity on land. So for example, people use sound to record birdsong in forests, or they use it to record bats in the night, or they use it to record frogs. And there's lots of these animals that people don't measure them by looking at them. They measure them by listening and by recording the sounds. And you can see in the green here, you can kind of ignore these two. These two comparisons are, they're for different types of hydrophone that we don't really use underwater, different types of microphone. But this one, this autonomous recording unit, this is really what we need to use underwater. And you can see that in blue, all of the ones that are commercially available now for use in underwater are all really expensive. They're way above $1,000. Sometimes they're up near $10,000, really expensive pieces of kit. Whereas on land in the green, there are many of these low-cost recorders for around $100 or even less than $100 in some cases. So we thought, can we change this? Can we create some underwater devices for listening that are much more affordable, that would allow other people to do this? The easiest way to do that, we thought, is rather than invent something new, why don't we take something that is already in existence, already being used on land, and just see if we can make it waterproof? And so we had two ways of trying to find cheap ways of listening underwater. And the first was we thought we could use GoPros because these are much cheaper than $3,000, although they're still expensive. But a lot of people have them already. You know, a lot of these programs that are doing conservation or restoration, or people who are interested in coral reefs, a lot of them own some sort of underwater camera already. And those cameras record sound, they're waterproof. So we thought, well, why don't we test to see if they can take a good enough recording to be useful for this? And then the other approach we took was we used this machine here. This is called an audio moth, and this is the cheapest of the available terrestrial recorders. So this is a microphone that was developed for $80 US to allow people to, in an affordable way, record birdsong, record bats, record frogs. And so we worked with the people who developed this and said, hey, you know, how about making an underwater version? And then we can test it, and we'll see if this technology works underwater as well. So they made a waterproof box for it, and then they changed their name. Instead of calling it an audio moth, now if it's waterproof, they call it a hydro moth. And we tested this. So with both of these devices, what we did was we tested the performance of the expensive one that we were previously using against these cheap ones, against the GoPro and the hydro moth. And they were quite similar papers. They're down here. I'm just going to present you this one, the hydro moth findings, because it's really very similar to the GoPro. You can find both of the papers there. And so these are these hydro moths. You can see each one of them. You can see here's the device close up, and you can see here's 5 of them all on a string, all in their waterproof boxes, glued shut. And we were deploying them like that next to a sound trap, which is the expensive one. And here again, this is recording next to a clownfish. This guy here was recording where he knew there were some dolphins in South Africa. So we took them to lots of different places in the world and recorded lots of different things, sometimes artificial noises, sometimes like dolphins and whales, sometimes coral reef fish, lots of different things. And you can see here's the start of the graph, and there's the full graph. And this is recording, again, so some different fish. We think this one was a damselfish, and then a killer whale down here. We think this was a toadfish. And in each case, these are recordings that have been taken on the left by the $100 hydro moth device, and on the right by the $3,000 sound trap device. And you can see that on the whole, they're quite similar. The one on the left, the cheap one, it isn't quite as good. So you can see, for example, here on this top box, you know, there is some disturbance. It's not quite getting the full range of the sound that the sound trap is getting, and where it should be quiet, you know, in these dark blue bits, it's not quite as dark. There's still some interference. You see that here as well. You see it's very dark blue on the expensive device, but a little bit messy here. But we think it's probably good enough for many purposes, and for many monitoring purposes, and for a lot of the research that we're doing as well. We think actually maybe we don't need this very expensive one here. Maybe we can make do with this cheaper device. And what that might allow is for many, many more people around the world to get involved with listening underwater, to take their own recordings, to do their own research, to do their own monitoring, and then eventually maybe to feed into a big global effort where you could take hundreds, thousands, even millions of recordings if it was much cheaper. That would allow us to understand a lot more about the sound of the underwater world and take the research a lot further. So we think making and using these affordable devices is probably an important next step in taking our research in underwater sound further. And then the final thing that I'd like to talk about today is possibly an unexpected use for all these underwater sound recordings, but one that I think is very important. Because we found that we could also use these sounds for public engagement. And this surprised us a little bit at first, but then the more we started doing this, the more I think this is actually a very important application of this science. Because we found that when we talk to people and when we told people that, you know, we record the sounds of the underwater world and we record all these weird fish noises and these, you know, weird sounds that the fish are making, people were very surprised by it. very interested by it. I think a lot of people didn't know that fish make noise at all. They expect the underwater world to be silent. They expect these fish don't make any noise. And then when you play all these weird sounds, they find it really funny. They find it really entertaining. They're really interested by it. And we thought, actually, this is quite a good opportunity to engage people in a conversation about environmental sustainability and about the importance of reducing carbon emissions, the importance of increasing interest and awareness and investment in conservation. And we found that when we showed people pictures, they'd kind of seen it before. It was, that they'd heard, that it was a message that they didn't engage very much with. Whereas when we talked about the sound of these ecosystems, something about that made an emotional connection and made a depth of engagement which was much, much greater. And if we're honest, we still don't quite understand why that creates these reactions in people, but I think it does. I think when we use a multi-sensory, when we engage in a different angle from usual with public engagement with science, then we see a real change in the way that people react. And so it's difficult to get a lot of data on this, but we have some examples. So these are places that we shared our work and talked all about weird reef sounds. So these are radio stations and TV programs and festivals in mainly in the UK, some in America, some international as well, so sort of television documentaries, magazines, that sort of thing. And then collecting some of people's responses. And this to me was quite encouraging because there's a whole range of different people, right? From 8-year-old children, builders and vicars and politicians and but people much older and teachers. They all found them very sort of weird. They'd not heard fish making noise before. And it's like, oh, it's cool, oh, it's funny, it's amazing. But then also there was this real emotional connection when we then showed them the recordings of the reefs dying and the noise stopping. They found it really quite shocking, quite emotional. It moved them. And then actually, in a lot of cases, we even found a behavioral response. So people talking about, going vegetarian, or talking about not using their car as much, or wanting to vote for greener policy, or thinking actually this is really important to protect nature more, or wanting to reduce their carbon footprint and all of this. And I think this was quite an encouraging reminder for us that when we do our science and we share our science, it is not just the reefs themselves that can benefit and the immediate benefits of the science, but actually it's part in a wider conversation about global responses and societal efforts to reduce climate change can be quite effective as well. And I think it's a really important thing for reefs worldwide, isn't it? We all know that restoration is only going to work if governments around the world and people around the world can really reduce CO2. And so by contributing to that conversation as well, I think this is a way in which this can be valuable. So just to come back to the start again, I'll stop sharing in a minute and then we can have a wider discussion. But just to finish by coming back to where we started, I think by thinking of reefs as whole ecosystems rather than just coral that we're trying to restore, by trying to bring back the whole ecosystem, we can think about it in new ways. We can understand the way the ecosystem functions in new ways, and we can connect with other people about climate change and about coral restoration in new ways. And so we have done that using the soundscape of a reef. I think it would be just as possible to do that by thinking about other elements of the reef as well. So by thinking about fisheries and reproduction and biodiversity and structural complexity and many more elements of reef ecology that I haven't even mentioned on this slide. So I would encourage all of us as we go forward and as we develop our new science to think beyond just planting corals, and planting more corals and just doing that, but starting to think about what else can we understand about these ecosystems? What else can we monitor? What else can we try and rebuild? How else can we understand the development of this whole system? And then how can we talk about it with the wider world in ways that will interest people, that will engage people, and will make others want to come on board and protect these ecosystems that we all love trying to conserve and trying to protect and trying to understand. So thank you again for including me in your discussion, in your group. It's been a real pleasure sharing our work, and I really look forward to hearing some of your ideas and being part of the discussion with you as well. Thank you very much.
Thank you very much, Tim, for this very interesting talk. If I may highlight a few of your talk today, then it means when we could hear the soundscapes of the coral reef, the restored coral reefs that yeah, pretty similar with the natural one, then we could say the restoration is being success, right? Okay, we have about 35 minutes for discussion, so I will open the discussion session. If anyone has any question, this is a very interesting topic. You could raise your hand or yeah. Okay. Oh, okay. This is one question from from Andre Saputra. And he said, "Hi Tim, great to see the presentation, very inspiring. I first saw this in BBC News article. I think it was Professor Steve Simpson's research at Northern Great Barrier Reef. One question, how do you filter the noise from boat, other vehicle, or other noise that is not your interest? Thank you." That's the first question. So
thank you, Andre. It's a great question. It's a really important one. And yes, so just for some background on that, Professor Steve Simpson he was my PhD supervisor. He's the professor I was working with for many of those years. He's been doing this research around the world. Some of it, yeah, as you say, on the Northern Great Barrier Reef, others in the Caribbean, in Indonesia, in the Philippines, in other areas in Australia. He's been doing this for maybe 20 years now. And so he's who I was working with in my PhD, and he's continuing to do that work as well. And yeah, the importance of human noise pollution, both for filtering it out when it's not of interest, but also I think for considering it, and considering the impact of that, because that's another side to this story that I didn't cover in today's presentation, but is an important one to consider as well. So I'll answer this in two different ways. Firstly, for our research, how do we filter it out? How do we get rid of it? We have two ways of doing that. The first is to do it automatically. And so there are computational filters which can be built to identify the noise of boats and remove those recordings from the analysis. Or we can do it slightly more simply, just using like a filter that will measure when the noise, when noise at a certain frequency or at that certain pitch of a boat, when it exceeds a certain threshold and gets so loud, we can go, oh, there must be a boat there. And then the second way is we can just do it manually. So we can just listen for each recording and identify where we see boats and remove that from the analysis, so they're not confounding the results. But also I think that highlights an important issue, that there is another whole field of research in coral reefs, but also in many other marine systems, that's looking at the negative impacts of noise pollution. And so the sounds of boats, of shipping, of industry, of seismic exploration, all of these human noise sources can be very loud, can be very distracting, can be very damaging for marine life, both on coral reefs and in other systems. And there's a whole parallel research field which is looking at the negative implications of that noise and how we can do human activities in the ocean in ways that are quieter, in ways that are less harmful, causing less noise pollution. So that's worth looking at as well. And that's Steve Simpson is one person who does research on that as well as the other half of his research group, my old colleagues. And there are other researchers around the world as well looking at that and trying to address policies and technologies that can help make the oceans a less human noise dominated place.
Okay, thank you, Tim, Mbak Ade Tris Razak already raised her hand. So please, Mbak Ade.
Hi, Tim. Thanks so much for the great presentation. It's really nice to know, like, you know, like the depth of your previous research on this. So my question is, like, when you following, like, how many different noises from an average, like for instance, the one that you found in the restoration site in Badi or in Bontosua, how many of those different noises can you identify? And have you ever done any comparison to other parts of the world or different efforts in restoration? And do you use that to quantify the success of restoration? And also, I think this is the fourth question. How long did you put actually the sound recording underwater? And at what time, or what is the methods that you use? Thank you, Tim.
Thank you, Tria. So really, really great questions there. So to try and address them one by one. I'll start with the most recent one, was the length of time and the methods that we use for the recordings. And this really can be quite different. And in the work we've done over the last 5 years, we've used some quite different approaches. So some of the time we've been interested in long-term patterns in the soundscape. So we record for many days at a time, so for weeks or even for months. Some of our partners are recording for years at a time. And that's because they want to understand the changes through the day, the changes through the lunar cycle, even the changes as the seasons change through the year. And so then they're recording for a long, long time and then doing the analysis after that. In other cases, we're recording for very, very short amounts of time, you know, even just minutes or hours. And so it really depends on the research question. So for example, in that one where we were comparing the restored reefs with the healthy reefs, we didn't have to record for that long because we were recording reefs that were very nearby at the same time as each other. And so we knew that comparison would be valid because they're recorded on the same day. And so we just recorded for 24 hours in each case. And then we did that several times on different days at different times of month. And that was how we did that one. In terms of how many of the reef sounds that we can identify, at the moment, there's not very many at all, is the answer. And so whilst there's been estimates, I think there are probably thousands or maybe even tens of thousands of fish that can make a noise around the world. There's very, very little understanding of which fish are making which noise at the moment. It's really quite a new field. And so the vast majority of the sounds that we're recording, we're just recording them as, like, you know, sound X, sound Y, mystery sound number 1, mystery sound number 2. You know, we don't know what the sounds are, but we know that when we hear a wide diversity of lots of different sounds, that reflects an ecosystem that has a wide variety of different animals. And so it reflects greater biodiversity. I think that is likely to change over the next few years, because what we're seeing now in the field is a lot of efforts to collate what people are calling like a library of underwater sounds. And so there's lots of those efforts worldwide from different institutions, all trying to bring together hundreds and thousands of different recordings and then use machine learning to try and unpick them and identify all of them. And I think from that effort, we will start to see many, many more sounds identified. And this tool will become more precise and more useful as time goes on. That's what we saw with in previous decades, you know, the research that was done in tropical forests on birds, or the research that was done on whales and dolphins. You know, previously they didn't really know what they were listening to. And then when they collected loads and loads and loads of recordings, they were able to start to identify more accurately. And now they're in a position where almost any of those sounds, when they play the sound, they can be like, oh yeah, that's that bird, or that's that whale. And I think coral reef sound, you know, may get to that point in the coming years, but it's not as far progressed right now.
Okay.
Thank you, Tim.
Okay, thank you, Tim, for the answers. We have several questions. Our head of department also raised his hand, but before that, there's an idea, or perhaps you could give more information about that. Since you already observing the soundscape of a coral reef ecosystem, is there any possibilities to restoring coral reef by using the soundscape that we already have to recruit more variable of fishes? That the first one, and the second one is from Fatima. She asked about, generally speaking, most of the people doesn't understand how important the reef are for ecosystem. Is there any easy way for them to be involved in this project? I think those two questions first. After that, I will give the head of department to pop up his question to you, Tim. Thank you.
Great, thank you. So I'll deal with those two questions one by one. The first question was about, now that we've collected reef sounds, is it possible to use them to attract a further to attract other fishes and to use them in a way that's beneficial for restoration? I'm glad you asked this question, because this is something we've done work on in the past that I didn't have time to include in today's presentation. But I've just put a link in the chat to the paper, and maybe I'll just very quickly share my screen now and show you this paper that we did on that topic. So this was work that we did in Australia, and we're asking this question. We're asking whether it's possible to use the sounds of a healthy reef to attract fishes to an area of degraded habitat, you know, and possibly might that be a restoration tool? If you're trying to rebuild a reef, can you call in the fish using the sound? And what we found was, so I'll just take you down to, this was the methods here. And so around Lizard Island, up in the north of Australia, we built lots of these little piles of experimental coral rubble, just very, very small little piles of rubble, some with no loudspeaker at all, some with a dummy loudspeaker that wasn't playing any noise. So it's another experimental control, and some with the sound of a healthy reef, acoustic enrichment. So even though it's just a pile of rubble, it sounds like it's a really healthy reef. And what we found was, we then measured these reefs for 40 days, and we found that the red and the orange are almost completely overlapping here. But we found that over that time, some fish come back to the rubble, even when it doesn't sound like anything. But we get many more fish coming back and staying and forming this community when we play the sound of a healthy reef. So after 40 days, there's about twice as many fish. And we found that that's a pattern that across lots of different types of fish, so the herbivores, the omnivores, the planktivores, invertebrores, even piscivores, we found that on the blue reefs with the healthy sounds, there's more of them coming back. So to an extent, yes, there's a sense in which we can play these sounds and attract fish, but I think there's a lot more work that still needs to be done in this area before this is a viable solution and a scalable solution. And there's several reasons for that. I think the first is that there's a lot of biological questions that still need to be answered. So I think we need to understand where these fish are coming from, whether this will actually bring in any adult fish, because all of this was just tiny little juvenile fish, and whether those fish will form a healthy community, or whether this is only a short-term impact. And then the other reason, aside from the biology, is the technology, because these underwater speakers are very expensive at the moment, so they need to be made cheaper, and they're also very difficult to deploy. So for this experiment, I was having to go out every single day, change the batteries, make sure nothing was broken, you know, reset the connections, reset the MP3 players. You know, it was a very difficult system to work with. And so, although I think this is an encouraging starting point, I think this idea needs much more development before it can be applied in a restoration context in the real world, as it were. My old research group are continuing with this, and they're continuing to do some of this work. But yeah, it was slowed down quite a lot by COVID. So I think they're just starting to get back out into the field and starting to produce these loudspeakers again after the COVID recovery. So that's that idea. And then the other one was the question about most people don't understand how important reefs are. Is there an easy way to get other people involved in the project? And yeah, I think this is a really good question, and there can be a lot of encouragement, I think, taken from those other fields and those ecosystems which are ahead of us in their development of these technologies. So, for example, some of the rainforest ecosystems where they're using microphones and sounds to record the sounds of rainforests have quite big citizen science programs involved where, you know, anyone can go online and listen to these recordings and identify the birds and the animals, and you know, it becomes like a place where people can understand and get more involved with their ecosystems. And the same with some of the whale song. You know, you hear all sorts of things about, you know, people including whale song in like music or in, you know, art exhibitions or in films and all this sort of thing. And I think it's another way that you can bring people closer to that. And that really is some of what we were trying to do with those, that bit at the end when I was speaking about public engagement. You know, we're trying to get these reef sounds into, you know, museum exhibits and, you know, on the radio and TV and other popular culture places, and make this more of a mainstream conversation, and more people hopefully excited by and involved in this sort of conversation.
Okay, thank you, Tim. I hope the question, I think, is really a good answers for that, and I hope it is an insightful answers to the questioner. And Pak Hawis, you can, yeah,
okay,
ask.
thank you.
Yeah, okay.
Thanks, Tim. As expected, it's really interesting. So,
thank you.
So this is our goal, is actually put more science to reef restoration, and then your discipline is kind of like put something on it, and then we need to evaluate every single reef restoration method or something into success, and then how to measure the success is actually can be very different way how to achieve that. And I have questions related to your research. How do you make sure that the sound as you record it is coming from the reef restoration? It's not coming from surroundings. Do you put something like the distance and everything before you put it in? The second is, since you already have established many sounds from the reefs, do you have database for that? So it will be comparable if anybody from the globe to study about the bioacoustic and then want to compare, okay, this is sound from the Amphiprion or Celaris, or this is coming from something that we don't know, but probably other part of the world found it easily with their eyes, with the sound, and then can contribute, something like that. So the one that there are two something that you showed us that haven't known yet. So and then the last one is, because we are talking about the reef restorations, how many reef restoration method has been tested for this kind of method, or is the one in South Sulawesi with the spiders is the only one, or you have been tested to other place? I think that's all. Tim, thank you very much for your contributions.
Thank you very much, and thank you for those questions, which are all excellent, and thank you again for inviting me to participate. I completely agree with you that the importance of understanding all of these different restoration methods. They all have different successes, different ways of working, and I think they all probably work differently in different contexts, you know, in different types of environment. And so it's very important to understand all of them and to measure success in different ways, not just measuring the coral, but measuring all sorts of other things about these ecosystems. And so I'll do your questions in order. So that the first one you asked was about how do we know the sound is coming from the restored reef and not from the surroundings? It's a really good question, and I think there's several ways that we can do that. The first way, I think, is by taking recordings through time, and so if and this is the same with any monitoring, isn't it? It's important not just to monitor the reef after the restoration has happened, but we have to monitor before the restoration starts, so that we can then see what the change is when, and the restoration impact. And I think that's the same with the soundscape. One good way of isolating the effect of the restoration is to take recordings before the restoration happens, and then again after, and then again a year later, 2 years later, 3 years later, and so we can build up this time series. I think the other way in the case of sound that we can do it, and what we've done in the past, is as well as recording on the restored reef itself, we can record at different points going away from it, and then if you're going into degraded habitat or into the open ocean, we often see that it's getting quieter and quieter and quieter and quieter as we go away into the distance. You can see my hand disappears into the white there. And it's, you get that sense of the center of the sound producing area is usually in that restored reef or on the reef. And then as you go away over the sand flats, you can hear it getting quieter and you can hear the profile of the sound changing. And so I think you can get a scale of the impact in that sense and where the sound's coming from. All right, your next question was about a database of underwater sounds that can be used to then make comparisons from site to site. And yeah, I think you've identified here one of the most important things that needs to happen in this research area over the next few years. This is something that a lot of people in my research area, a lot of my colleagues are talking about. We need to have this database, this library of recordings, so that we can make comparisons. And in fact, I'll point you towards a paper that was published just this month by some colleagues of mine. There's a link in the chat there. It's called Sounding the Call for a Global Library of Underwater Biological Sounds. And in that paper, they're basically saying, yeah, we need this database because it will allow us to answer so many more questions, allow us to organize our research so much better. So yeah, you're absolutely right. You've identified what these others have identified. And I think that they will be starting this database quite soon. And I think in the area of bioacoustics, that will be a very exciting development. I'm excited to watch and see where that goes. And I've contributed some recordings already to this database. Hopefully many other people have as well. And then together it will be quite a powerful thing. And then your final question was how many different restoration methods have been recorded? Have we tried the sound of? And at the moment, it's only really this one in this level of detail, that we've done like a full study on. There's been lots of other places around the world where we've set, people have contacted us and said, hey, we're really interested, and we've advised them to, on which hydrophones to get, and they've started taking recordings. And there's others that are, works in progress. People are talking about starting to record the sound of their ecosystems. But this is the only one where we've sort of done a full study. And I think that's partly because this is a new area, partly because, as we were saying, the technology has until very recently been very expensive. And also partly because I think there are lots of different ways, aren't there, of measuring a reef. It's important to measure the coral, important to measure the fish. In our case, we've been measuring the soundscape, but others are focused on other variables as well, measuring the structure of it, measuring the chemistry of it, maybe measuring the eDNA. There's lots and lots of different avenues of looking at an ecosystem. And I think some of the others are also fantastically exciting. In fact, I've just started a new role here in Lancaster University, where, as well as looking at the sound, I hope to now be looking at many other aspects of the reef ecology as well. And so I'm personally quite excited to be looking at different aspects like that too. And I hope that's something that I can do over the next 3 or 4 years. yeah, I hope to collaborate with lots of new people in lots of new areas and try and understand all these different ways of looking at reefs, as well as sound and sight.
Thank you, Tim, for the great answers. We have 2 more questions, but before that, I also have one question because, well, as I told you, I'm not very familiar with this bioacoustic things, but far as I know, soundscapes or a sound is all about vibration. So when you mention you already, and you and your colleagues already applied the collectible soundscape to the restoration procedures, is there any possibilities that the sounds, that the collectible sounds neutralized by the, I don't know, substrates or anything in the environment, so it will reduce the possibilities to make it more accessible application. And we have 2 questions. Should I ask you? We have a question too from Adin Masni. I don't know, she or he asked, what are the important variables and information that need to be investigated prior to the utilization of bioacoustics in reef restoration? And the last question is from Bapak Mujianto. He asked about what specification equipment which you use to record as long as your research? How many far did you put the recorder from covering one research area? Is the recorder head specific, like kilohertz or the range of decibels? I have a recorder for cetaceans to analyze their voice. It's SQ26H1. Does it can use for it? That's all the questions. I hope we still have many times to answer that. Thank you, Tim.
Sorry, I'm on mute. Again, thank you. Some really great questions there. So I'll take them in order again. So your first question was about the impacts of the seabed and the benthos and the material, because as you very correctly say, sound is vibration, and these vibrations will be affected by the material of the seabed and the surroundings. And yeah, we see that a lot, and so we find that the depth of the water makes a big difference in how far a sound will travel, and how well a sound will travel, and what a reef will therefore sound like from different distances away. And that's because as the sound, you can imagine in very shallow water, the sound bouncing a lot in between the surface of the sea and the seabed. Whereas if it's much deeper water, then those bounces happen much slower. And so the way that sound travels is different. It also depends on what the seabed is made of. So for example, if it's a really hard material, if it's like rock or like very smooth, the sound will bounce off very well and continue to travel. But if it's like really soft mud, it's just like, you know, the sound doesn't reflect off as well. And so it gets like insulated almost. And then also it depends on the shape of the reef. And so if in areas where like the reef is very complex, lots of, you know, caverns and things, then the sound will sort of get trapped and won't reverberate out as much. Whereas if it's nice and smooth, again, it will reverberate out a lot. So this is quite important in modeling how sounds will travel around the ecosystem and how far the ecosystem sound will spread. And so, for example, there's been, it can be beneficial or it can be, you know, harmful in terms of when we're looking at noise pollution as well. So for example, if there's been times when we've been working on some reefs where if there's a busy shipping lane, the reefs on the one side that's close to the ships will have a lot of noise pollution. You know, that you'll see a lot of impacts. There'll be a lot of stress on those animals. Sometimes you see some animals just not living there at all because, you know, they need the acoustic, they're acoustic specialists. They need to be able to use these natural sounds. And so when they're on the side of the reef that faces the ships, then they won't live there. So we find on some reefs in Polynesia, in the Pacific, we've measured where the boats are driving, and then we've looked at the different communities of fish in different areas of the reef. And those fish that are acoustic specialists, they just don't live where the boats are at all. And yet when you go to a different bit of the reef that is sheltered, and so there's like a reef wall between the fish and the boats, or an area where the structure of the reef has created like a quieter section, then they'll be there instead. And so you know, across a reef, you can see differences in the way sound behaves, and then resulting differences in the community. So it's a really, really good question. And then the next question was about identifying important variables and what information you need to collect before investigating bioacoustics of reef restoration. And I think this is a good question as well. This talks, you know, to the importance of good monitoring before and after, doesn't it? Because I think bioacoustics is at its most valuable when it's combined with other ways of measuring reef health. So at the start, I showed you that Venn diagram where on the, you know, there's some animals that you can hear and you can see, but there's lots of animals that you see but you never hear, and other animals that you hear but you never see. So I think it's most powerful when you can have a program that looks from lots of different angles really well in all cases. So I think it's important to measure before the restoration starts, as we discussed earlier, so that you know the change when the restoration has been put in. And then also to use different methods of monitoring these reefs. So measuring the coral, but also measuring the fish visually. And then if there's an interest in bioacoustics, measuring the sound of the reef too. And so I think, yeah, lots of points through time and lots of different methods of monitoring are both really, really good ways of doing restoration monitoring. And then the last question was this one from Meutia about the equipment. So the specifications of the equipment and how far we put the recorders apart. How far, I think, depends how much detail you want. And so we've done some studies where we've just had one hydrophone on one reef, and we only had one hydrophone. So you do that, it's better than nothing. But in other cases, I think we've put them on, you know, you put many around a reef and you hear different things, of course. And so in the past, we have found that you hear quite a different thing if you put one like even 50 meters away. Then you'll hear different soundscapes. But I think it depends on what your research question is, really. And sometimes it's not necessary to have that level of detail. You know, what one recording can be representative of a wider area if you're asking a more general question. As for the hydrophone, this one you have is an SQ26H1. I've just looked up the specifications of that, and it's quite a general purpose hydrophone. I think a lot of people are using it for whale watching, and it's full band, and that means it can record low pitch noises and high pitch noises. So that's good news, because that means it's quite applicable to a lot of different settings. So it's likely that you will be able to use this hydrophone for recording reefs if you'd like to. You need to plug it into a recorder, you know, a handheld recorder on a boat. And in general, when we listen to reefs, most of the noises that we find are between about 50 hertz at the lowest end of the frequency spectrum, up to, we've never really recorded above 20 or 24 kilohertz. Really, lots of the whales and dolphins are making noises much higher pitched than that, but all of the fish really on a coral reef are making noises between like 50 hertz and probably like 1000 or 2000 hertz, so 1 or 2 kilohertz. And less above that, really, you're just hearing the shrimp on the reef, and they'll go up much higher than that. So then we'll go up to like 20 kilohertz, capture loads of the shrimp noise. And then, yeah, if you're not interested in recording cetaceans, then there's not much point recording above 20 kilohertz. So it depends what you're trying to listen to.
Okay, thank you, Tim. We're about on time because the schedule is 15, half past 15, and we have already get to 5 o'clock now. Thank you very much for this very insightful and interesting talks. If Julia Caesar said "Vini Vidi Vici," we came, we see, and we conquer, then hearing is as much as important with seeing. So we should add one more term in that quotes, I think. So before I give it back to Mbak Tris Razak, I would like to say thank you very much, Tim, for this talk and for all the attendants for spending your evening time with us. And I hope this talk will, elaborate, can make a new elaboration on our research in the coral reef restoration. Thank you, Mbak Ade. I give the time and screen with you. Thank you.
Okay, thank you so much, Tim, for agreeing and then sharing with us. It's been, I think, like a lot of ideas, a lot of knowledge. I just hope like maybe in the future we can build a strong collaboration, with your knowledge on bioacoustic, and maybe any staff at the uni or anyone participant here would like to pursue this, for further research. We know there are a lot of things need to be done for the conservation of coral reef in Indonesia. And again, we agree on we try to explore as many methods, as many monitoring methods to quantify, the success or the failure of our program. So this bioacoustic that you've shared been really useful and give us more ideas for our future works in Indonesia. Thank you very much, Tim. And I can say, we have a record of participants, almost 100, and staying all the way, from the beginning to the end. So I think it's very difficult to divert from such a very interesting subjects. And thank you very much for Tim. And maybe Pak Hawis, do you want to add something to it?
Yeah, I would like to extend our gratitude to you, Tim. Thank you for sharing with us. And one of our colleagues is interest to the bioacoustic is Professor Totok Hestiarianoto. Here, he's coming here. Probably he will contact you because he is also doing research related to bioacoustic and probably can extend more collaborations between our universities. Yeah, thank you very much, Tim, and then thank you very much for all attendees. It is very fascinating sessions and very inspiring and bring us many questions further. And I think this is a good signal because as mentioned that we need bring more science to reef restorations. Any discipline can contribute to evaluate the progress, whether it's failure or success. We need to know, and then we need to assess that. Thank you very much, and then see you in the next course next week.
Thank you very much, and thank you for inviting me again. A real pleasure to join your group. Thank you very much, all of you.
Thank you, Tim. Bye, everyone. Have a good afternoon. Have a good day, Tim. Bye-bye.
Bye.